Okay, we'll look at some long division here. First we do some long division using integers, and then we'll look at some long divisions associated with polynomials. So let's just review long division. Not so much that long division is hard, but the mechanics of the long division with integers is the same as long division with polynomials. So we have 7, and we're dividing that into 78. So the question is 7 times what number gets written up here, equals 7. Well, 7 times 1 gives me 7. So we write the 7 down here. And then what do we do with these two numbers here? Well, we subtract those two numbers. So in essence, what I'm doing is I'm going to use the words I change the sign of this 7. So I put a negative in front of this 7. That 7 is positive. Now it's negative. And now I do 7 minus 7, which is 0. And I bring down the 8. And I say 7 times what gives me 8. 7 times what? Well, the what goes up here, so 7. So then I actually do the multiplication. 7 times 1 is 7. I'm then going to change the sign of this 7 to a negative and do 8 minus 7, which is equal to 1. So, not that long division is hard, but I'm going to use this same idea when I'm doing long division with polynomials. Just to go over some of the vocabulary here. This number right here, the 7, is known as your divisor. The 78 is known as your dividend. The 1 is our remainder. And the 11 is our quotient. Not that there'll be a vocab quiz, but it's important that you know those words. It's also known that 78 is equal to 7 times 11 plus 1. So the divisor times the quotient plus the remainder equals the dividend. Or 78 divided by 7 is equal to 11 plus 1/7. How did I get that? Well, I just took this and divided all of them by 7. And I get this same statement right here. You remember back in elementary school when you wrote down the remainder, sometimes you wrote down the remainder as R1, or you wrote it down as 1 over the divisor, 1/7. Well, that's what this statement says right here. So here's a quotient of polynomials. Again, here is my divisor, and this is my dividend. So the x plus 3 goes on the outside of my division symbol, division bar. I don't really know what that's called. X squared minus 6x minus 27. So the question is, when I divide x plus 3 into x squared minus 6x minus 27, what is my quotient going to be? Let's just look at x squared minus 6x minus 27. Hopefully you notice that, oh, well, the factors of 27 that give me 6 are 9 and 3. So that's x minus 9, x plus 3. So what happens when I divide x plus 3 into this? I should get a remainder of 0 because x plus 3 is a factor of x squared minus 6x minus 27. And when I divide x squared minus 6x minus 27 by x plus 3, I should get x minus 9, excuse me. So I should get an x minus 9 up here. So this is one of the most important terms when you're doing long division with polynomials, that you always want to look at this number here, this term here, and see if how many times it divides evenly into each applicable value. So the first thing we do is we say x in x squared. We say how many times does x go into x squared, or x times what gives me x squared, or you can just write down over here x squared over x is equal to x. So therefore, what I do, since this is a linear term, I line it up with the other linear term and I put an x right above it. The purpose behind doing that is when I get to the end, when I get to this 27 over here, I know that I've finished my division and I'm just going to have remainder after it. So the next thing I do is I take this x and I multiply it by both of these terms right here. So x times x is x squared. X times 3 is plus 3x. And now I'm going to subtract these two, or I'm going to change the sign. So I'm going to get a nasty color here. I'm going to change the sign of those two terms. So they were both positive, and now they're negative. So now I'm going to combine these like terms. These two cancel out. If the lead terms don't cancel out, that means you did something wrong. Then I have negative 6 minus 9, which is negative 9x minus 27. I then use this key term here and say this number times what gives me negative 9x, where my what goes up here, or negative 9x divided by x is equal to negative 9. So I write a negative 9 here, and then I multiply this negative 9 by both of these terms out here. So negative 9 times x is negative 9x. Negative 9 times 3 is negative 27. I'm going to change the sign in both of these. So this negative 9 becomes a positive. This negative 27 becomes a positive. And then I just combine like terms. So these two cancel, those two cancel, I get 0. So again, this is our remainder. This is our dividend. Here's our quotient. And lastly, this is our divisor. And notice that we said that x minus I times x plus 3 is equal to our dividend, x squared minus 6x minus 27. Well, if I take this and multiply it by this, I should get this because I have a remainder of 0. Well, that shows that x plus 3 indeed is a factor of this quadratic here, x squared minus 6x minus 27. Okay, let's look at another example. So this is just a little bit bigger. Again, we still have a binomial that is our divisor, but our dividend is a little bit bigger. It's a quartic. But notice there's no cube term. So to make things easier when you're doing your long division, I typically put a placeholder for the missing terms, which in this case would be 0x cubed, because by putting 0x cubed in here, it doesn't change this polynomial at all. But then I have 4, 3, 2, 1, and then this is x to the 0. So therefore, my divisor is 2x minus 1. Nice line. And I'm going to write it as 4x to the 4th. Excuse me, let me fix that. Now I'm going to squeeze in that 0x cubed, and then I have the 3x squared plus 3x minus 2. So then the question is, how many times does 2x go into 4x to the 4th, or 4x to the 4th divided by 2x is equal to 2x cubed? So since this is a cubic term, I write it above the other cubic term, which is 2x cubed. I then multiply this 2x times both of these terms here. I get 4x to the 4th minus 2x cubed. I now change the sign of both of these, so this is now a negative and that's a positive. So I combine like terms. These two cancel. I'm left with 2x cubed minus 3x squared. And notice that my divisor is a binomial, meaning there's two terms. So I only need to bring down one additional term, so I have two terms to divide into. So then 2x times what, where my what gets written up here, gives me 2x cubed, or 2x cubed divided by 2x is equal to x squared. So this is plus x squared. I multiply this by both of the divisor, both terms of the divisor, so I get 2x cubed minus x squared. I then change the sign of both of these, so this is now a negative and that's a positive. So that gives me, so these two terms cancel out. Again, if they don't cancel out, you did something wrong. Negative 2x squared, I only need to bring down one additional term because my divisor is a binomial. So now I have 2x squared negative, that's a squared, divided by 2x gives me negative x. So I write a negative x up here. I multiply both terms, negative x times both terms of the divisor. So I get negative 2x squared plus x. I then change the sign of both of these, so this is negative, so now it's positive, and this is now negative. I combine like terms, those two cancel. I get 3 minus x, which is 2x minus 2. And finally, 2x times what gives me 2x? Well, that's just plus 1. Notice that I've reached the end, so I know that this is my last step of my division. So 1 times 2x minus 1 is just 2x minus 1. I change the signs. I add like terms, and my remainder is negative 1. So since 2x minus 1 has a remainder of non-zero, meaning negative 1, 2x minus 1 is not a factor of this polynomial here. But really, we're only interested in the mechanics of doing the long division. Let's try another example where the divisor is not a binomial. So again, our divisor again is actually a quadratic, and here I'm missing an x cubed term. I fixed that, and an x term. So I'm going to squeeze those two terms in the dividend. This is going down in degree by 1, so therefore my divisor is all set. So I go x squared plus x plus 1. And then I write down x to the 4th plus 0x cubed plus x squared plus 0x minus 1. I say x squared times what gives me x to the 4th? Well, that's just x squared. Notice that I line it up with the like terms so that I know when I get to the end I'm done with my division. I distribute the x squared over the divisor. I get x to the 4th plus plus x cubed plus x squared. I change the signs. This becomes, all three of them become negative. I add like terms, those two cancel. I'm left with negative x cubed. Those two cancel. Plus 0x. X squared times what gives me negative x cubed? That would be negative x. So that gives me negative x cubed minus x squared minus x, and obviously there's a 0x squared in here if you didn't see it already. And now we change the sign, so all three of these become positive. The like terms get combined, those two cancel. I'm left with x squared plus x minus 1. X squared times what gives me x squared? That's plus 1. So I get x squared plus x plus 1. I change the signs and combine like terms. Everybody cancels except this. I get a negative 2. So again, is x squared plus x plus 1 a factor of this dividend here or this polynomial? No, because we got a remainder of negative 2.